Hello, my name is Anthony Francione, and welcome to the Whitebox Geospatial YouTube channel. Today, I'll be providing you a quick tutorial on how to interpolate LiDAR data into a digital elevation model using Whitebox tools. This is a common task for GIS and geomatic professionals working with LiDAR data or other types of data when creating a DEM. For this video, we are creating a digital elevation model. This is not to be confused with a digital surface model, which captures the underlying surface, which can include forests, buildings, parked cars, and so much more. LiDAR data has the ability to capture multiple surface returns, and these returns can depict a much different representation, whether it is a first, last, or some sort of middle return. To create a DEM, we will be using the last returns of LiDAR data to create what is called a bare earth DEM. Before we get started today, I just wanted to go over the type of interpolation technique we will be using. Today, we will be using the Sibson Interpolation technique, also known as the natural neighbor interpolation technique. If you wanted to learn more about that tool, you can do so in the Whitebox Tools user manual, which can be accessed from the homepage under the software link on our Learning Resources page. Once on our Learning Resources page, you can navigate to the Whitebox Tools user manual. In the user manual, you can find tons of information on all the tools in Whitebox Tools, but specifically for the LiDAR Sibson Interpolation tool, that tool is located in the LiDAR toolbox, and then navigate to the tool itself. Sibson's method is based on assigning weight points for which inserting a grid point would result in captured areas of the Voronoi tessellation of the input point set. The larger the captured area, the higher the weight assigned to the associated point. One of the main advantages of this technique when compared to others is that there is no need to specify a search distance or another interpolation weighting parameter, which can take time to properly parameterize, such as inverse distance weighting or kriging. The LiDAR Sibson interpolation technique resides within the Whitebox General Toolset extension and requires a software license from Whitebox Geospatial. If you are interested in learning more about the LiDAR Sibson interpolation technique or any of the other tools within the General Toolset extension, check out the Toolset extension page on our website, which can be found under the software heading on the Whitebox Toolset extensions page. So now that we are familiar with the interpolation technique and what our task is, let's go ahead and create a DEM from LiDAR data. The first thing you're going to want to do is, if you have not already, is to download the Whitebox Tools Open Core to access the function in the Open Core library. And you'll want to activate the General Toolset extension as well, as we are using the LiDAR Sibson Interpolation tool and the LAS-to-LAS conversion tool, which I will go over in just a second. If you're unfamiliar with this process, you can check the previous YouTube videos on how to download and install the Whitebox Tools Open Core and how to download and activate the General Toolset extension. I have attached the link to each video in the description down below, so feel free to check those out. So to get started today, the first thing we are going to want to do is launch Whitebox Runner. First, open up a terminal window and cd into the directory that contains your Whitebox Tools executable. For me, that is in my documents in a subfolder called Anthony WBT tutorial and another folder called WBT. Once in WBT, which you'll see over here, you'll see I have access to the Whitebox WB_runner script, which I will launch with the command Python 3 WB_runner, and the Whitebox Runner front end will launch. The first step in creating a DEM from raw LiDAR data may require converting LAS to LAS data. LAS data is a common LiDAR data format that stores the LiDAR point information for each point. However, this file format is extremely large and should not be stored in large amounts on your personal hard drive, as it will take up a lot of space. LAS is a compressed file format for the LiDAR point information. It is on average 5 to 10 times smaller than LAS and is much better for storing its information. Commonly, when LiDAR is transferred from an online source to your computer or from a data supplier, it is usually transferred in LAS and will need to be converted to LAS to use it. The data set that I have for today is 4 LAS files that I gathered from an online source. So the first step I will need to accomplish is that I will need to convert the LAS to LAS data. Within the Whitebox Tools General Toolset, we have added the ability to convert LAS to LAS and vice versa. To convert LAS to LAS data, let's navigate to the LAS to LAS tools in the LiDAR toolbox. So on the left-hand side, you'll see the LiDAR toolbox. Open a toolbox and navigate to the last tool and launch that tool. When that tool launches, you'll see there is an input and output file user parameter. You can run this tool in two ways. The first, you can individually populate the input file with one last file and convert it to one last file. However, this can be extremely tedious when working with many last files all stored in a single directory. Instead, you can run this tool in batch mode by setting the working directory of this tool to the directory where your last files are stored. So I'm going to go ahead and show you how to do that now. So you're going to want to click on File, Set Working Directory, and you're going to want to set this directory to the location where your LAS files are stored. For me, that's in my Documents folder, in a folder I named LAS. You'll see the LAS files here. For me, they are grayed out as I'm unable to select the individual LAS files. I have to select the entire directory. Once you have set the directory, click Run. As you don't need to worry about setting an output file name, as this tool will output the exact same file name as input, except with the .las extension instead of the .laz extension. As this tool runs, I'm just going to pause this video in the essence of time, and we'll resume it when the tool finishes. So I've just ran the tool, and now I'm going to pause the video. So the tool finished. The tool executed in just over 53 seconds. Processed 4 LAS files to LAS, which is pretty quick given the restrictions of my personal machine from running the video editing software and also just being very old. So now that we have LAS files, we can interpolate these files into rasters using the LiDAR Sibson Interpolation tool in the General Toolset extension. Let's navigate to that tool in the toolbox on the left-hand side. Since we're already in the LiDAR Tools toolbox, let's just navigate to the LiDAR Sibson Interpolation tool. Click it and the tool will launch. As you see, this tool has 8 user input values. The input file is the input LAS file. The output file is the output raster file. The interpolation parameter controls what parameter in the LiDAR file to interpolate. The default is the elevation parameter, but you can select others such as intensity, class, return number, but we're just going to leave the default as elevation. Point returns controls which return points to use, which could be the first, last, or all. Since we are creating a bare DEM, we're going to want to use last returns, but if you were creating a DSM, for example, you may want to use first returns. The resolution parameter is the output raster's grid resolution. And last, the exclude class cells is an optional class to remove certain LiDAR classes from interpolation. Depending on the LiDAR data you have access to, it may be unclassified or classified. In many cases, especially LiDAR data sets provided by a data supplier, the LiDAR data will be classified according to 18 to 20 various classifications identified by the American Society for Photogrammetry and Remote Sensing. According to the American Society for Photogrammetry and Remote Sensing, LAS 1.4 specification, there are 20 classes that a point can belong to. I've actually pulled up this specification in a pamphlet I found on the internet, which is right here. And somewhere on this page, it does have the classification information. Just got to find it. Here it is. So you'll see that there are around 20 classes, and each class has a meaning. For example, a class of 0 means it's a never classified point. 2 is a ground point. 5 is high vegetation. 8 is water. 10 is rail. 18 is high noise, and so on. These classifications are extremely helpful to tell the end user which point belongs to which classification. This information could be used further for certain application areas, such as for forestry. However, for this purpose, we are trying to create a bare earth DEM, and thus all the information about vegetation, water, wire, and so much more is really undesirable for us. For this purpose, we really are only interested in class 2, which are ground points. So for this analysis, we're going to exclude all classes except for ground points. Before we exclude this class, a quick way to see if your data set or the file you're working with contains LiDAR data is to run your LAS file through the LiDAR info tool in Whitebox Tools. Let's head back to Runner now and have a look at that tool. So the LiDAR info tool, which is located in the LiDAR toolbox, will tell you a bunch of information about the input LiDAR file itself, such as the number of points, density, file type, classification, number of points in each class, and so much more. You could use this tool to see which classes of LiDAR points are contained within your file, which would be helpful in a situation like this when determining which classes to exclude. As a quick demonstration, I'm just going to run this tool on one of the input files to see which classes are contained within my data set. So I'm just going to pick one of the LAS files that I recently converted from LAS. This one seems good. Let's go ahead and run that. Don't worry about creating an output summary file report. The tool will create an output HTML file that will load in whatever browser you have open. So we'll see that this, for example, this is the file name. The last version is 1.4. The header size has information about the number of points. It does some point return analysis, which you'll see over here, but we are interested in this over here, the point classification table. So as you can see, 21% of points are unclassified. 78.9% of the points are classified as ground, which is very good for us in this case, as we're creating a bare earth DEM. 0.1% of points are low points, and lastly, 0% or 2,278 points are classified as high noise. Now that we know what types of LiDAR data classes exist in our file, let's navigate back to the Sibson Interpolation tool in Whitebox Runner and run the tool. Let's find the tool, LiDAR Sibson Interpolation. Similar to the last tool, we can run the Sibson Interpolation tool in batch mode and use the entire directory instead of each input file. So let's set the working directory to where our LAS files are stored. Let's set the working directory. As this directory, you see our LAS files are there, but also our LAS and our HTML file are there. Don't worry about that, as the tool will look for the file extension that ends in .las. So even though you have other file extensions in there, the tool will only specifically look for .las files. So you are safe doing it in one directory. But if you also wanted to break up the last, like put them in different directories, you could do that as well. But for the purpose of this video, I'm just going to do it in one directory, and I'm going to choose this entire directory. Once that is done, we don't need to set up an output file because the tool will use the name of the input file itself, but instead of the .las extension, it will use the .tif extension for a raster file. For the interpolation parameter, we're going to leave it as elevation. For the points return, we're going to want to switch that to last. Whoops. For the output grid resolution, let's do a grid resolution of 5. For the exclusion classes, we're going to exclude all classes except for 2, which is ground. So we're going to do 0, and the next class separated by a comma, and then it would be 2, but we're keeping that, and then it's going to be 3, and so on. Instead of actually putting 3, 4, 5, 6, 7, 8, and so on, we could just hyphenate it to 18. Lastly, the minimum maximum elevation parameters are optional parameters which control the min and max elevation values for inclusive interpolation. For this analysis, I'm just going to leave these parameters blank, as we don't want to restrict output elevation values. Once all that information is entered, go ahead and hit run, and the tool will execute. For the purpose of this video and the essence of time, I'm going to pause this video during analysis, and we'll restart it when it completes. So the LiDAR Sibson Interpolation tool has completed, and you see we have 4 output TIFF files. And now that the LiDAR Sibson Interpolation tool is executed, we have 4 individual output rasters for each tile. Let's take a quick look at one of these tiles in QGIS. I'm just going to open with QGIS and head over to QGIS. So there you go. So we do have a interpolated raster. Theoretically, if your DEM of interest was only one tile, you would have successfully created a bare earth DEM upon completion of the Sibson interpolation technique or any interpolation technique. However, it is usually the case that a DEM is a collection of many tiles, and in this case, 4 individual tiles are used in the study area and will have to be mosaicked together. So heading back over to Whitebox Runner, let's search for the mosaic tool. Here it is. Launch it. The mosaic tool will create an image mosaic for one or more input images of or raster files. In this case, we want to mosaic 4 rasters into one. To do this, we have to use the mosaic tool. So when the tool launches, you'll see three input parameters. The input file is a file dialog that can either be populated with each input file or could be ran in batch mode. The output file is the name of the output file. And lastly, the resampling method controls the resampling technique that is used to combine the images or raster files together. For the purpose of this video, we're just going to leave that as its default. So let's go ahead and populate the input file with our file rasters. So previously, I showed you how to populate it using the batch file mode by setting the working directory. But for this, I'm just going to show you how to go to the directory, select all the files, and add them. So the output raster files were in a directory I renamed as Interpolated Rasters. And I'm just going to shift and select the last one. And then all four interpolated rasters were selected. The output file I'm just going to name test_mosaic.tif. And like I said, I'm not going to touch the resampling method. I'm just going to leave that as the default. And I'm going to go ahead and click run. So the Mosaic tool is executed in 0.3 seconds. So we have successfully created our bare earth DEM from LiDAR data. So let's go ahead and actually view that file in QGIS. So we'll go ahead and view that quickly. Open with QGIS. Just going to remove that individual tile. I'll just put a quick palette on it. There we go. So this is our output interpolated, nearest natural neighbor interpolated raster using LiDAR data and Whitebox tools to convert the raw LiDAR data to a interpolated raster. Although we have successfully created a bare earth DEM, further DEM preprocessing may still be required. For example, the output bare earth DEM still may have some small missing data gaps that will need to be filled, or the output DEM could be extremely noisy, and thus we will need to use a filtering technique to smooth away this noise and error. However, this video was created just to show the process of how to take LiDAR data and convert it into a bare earth DEM. Further DEM preprocessing may still be required. In addition, this was just one of the many methods on how to create a bare earth DEM from LiDAR data. There are many other softwares and many other interpolation techniques that could be used. However, this is just the one method I chose and I felt comfortable with. That concludes this video. I hope this video has helped you to create a bare earth DEM from LiDAR data using the WhiteboxTools Open core and the General Toolset extension. If you have any questions, feel free to ask them down below in our Google group or send us an email at support@whiteboxgeo.com. Please subscribe to our channel for all new videos and updates. Thank you for watching.